Hello everyone, you're welcome to number 12 question of the 2011 May-June waec past question. Okay, I remain your tutor, Mr. Life Changer. So the question here is, what is an eclipse? Okay, well, we say an eclipse is a shadow cast by one heavenly body to another. So it is a shadow that is cast by one heavenly body to another. Okay, so here we are asked to mention three types of eclipse. The first one we call this solar eclipse, right? Or what we call eclipse of the sun. The other one is called lunar eclipse, or what we call eclipse of the moon, and we have annular eclipse. Okay, those are the three types of eclipse that we know for our level. Now the next one says a student in a lecture theater can read from the board clearly, but requires a pair of spectacles to read from a book. Okay, so what eye defect has this student? The student has long-sightedness because the student can only see a distant object. Okay, so the student is suffering from long-sightedness, or what we call hypermetropia. Okay, so the next question says, what type of lens is needed to correct this eye defect? Now, long-sightedness is as a result of short eyeball, and so since the eyeball has to be short, it means that we need a concave lens, a convex lens, in order to converge it. This convex lens is also called a converging lens. Okay, so when you say long-sightedness, it's as a result of short eyeball. So that means you need a convex lens to be able to converge this to be formed on the retina. Okay, that's very important. Now, but without this convex lens, this image will be formed somewhere here behind the retina. Now the next question says the focal length of the lens used to correct this defect is 10 centimeter. The power of the lens is simply 1 over focal length, which is 1 over 10, which is 0.1 diopters. That's the unit. Quite easy, right? Then we have the next question here. It says a car B moves towards a stationary car A. If B produces an ultrasonic sound at a point, and it takes 5.6 times 10 to the power 3 seconds for a beep to be heard in B, calculate the distance between the two cars at that instant. Okay, and we are given the speed of sound to be this. Okay, now at this point we can just simply say the speed is equal to distance over time. That's simply, and what it is. That means the distance should be equal to the velocity times time. The velocity here is 340, and while the time is 5.6 times 10 to the power minus 3. So let me use my calculator. I hope I have that here. So we have 340. So we have 340 multiplied by the other is 5.6. So let's see, 5.6. So that's 1904. So the whole of this is 1904 times 10 to the power minus 3, which is going to give us 1.904 meters, right? So that's the distance between both cars. Important, right? Now the D part says the image of an object is located 9 centimeters behind a convex mirror. If the magnification produced is this, calculate the focal length of the mirror. I think this is quite easy too. Given that the image is located at 9 centimeters, so I can say the image distance is equal to 9 centimeters, and is behind a convex mirror. A convex mirror, since the mirror is convex, it means that the image is definitely a virtual image, because convex mirror always produces virtual image, right? And because of that, it means that V must be negative. The V is negative, definitely. Okay, then magnification is 0.6. So magnification is simply the image distance over object distance, so equal to 0.6. So with this we can find u, especially since v is 9 centimeter. I can say 9 divided by u is 0.6. If you cross multiply, you are going to have u to be equal to 9 divided by 0.6, which is the same thing as 90 divided by 6. 3 here, 2, 3 here, 30. So which is 15. So u is 15 centimeter. Now if we want to find the focal length of the mirror, we say 1 over f is equal to 1 over u plus 1 over v. That's the mirror formula. And so we can say 1 over f is equal to 1 over u. U is 15, but this will be minus 1 over v. V is 9. You see, this is very important because this negative sign, because for a virtual image, v must be negative. And because this is a convex mirror, I expect that in my calculation, my focal length will also be negative. So let's see. The LCM between 9 and 15 is 45. 45 divided by 15 is 3. 3 times 1, 3. Minus 45 divided by 9 is 5. 5 times 1, 5. So that means 1 over f is equal to negative 2 over 45. So the focal length now is going to be 45 over negative 2, which is negative 22.5. It is expected that the focal length is negative because the mirror is a convex mirror. Because for convex mirror, focal length is negative. But for concave mirror, focal length is positive. So this is what it is all about, right? So thank you very much. See you in the next video.